The first feature we're going to talk about with the Diels-Alder reaction is the stereochemistry. And depending on your starting materials, we can get chiral products, and we have to think about the stereochemistry of that. Here's a simple Diels-Alder reaction where we start with this diene and dienophile, and what we see is that when we draw the product, we end up with two chiral centers. And that's something we have to consider in terms of what we get in the product. What is the stereochemistry of those chiral centers? So the first thing to keep in mind is that the Diels-Alder reaction is stereospecific. That's just a fancy term to say the stereochemistry in the starting material affects the stereochemistry in the products. Now, at first glance, you may look at these starting materials and ask, what stereochemistry? But remember that cis and trans double bonds are also a form of stereochemistry. In this reaction, cis groups on the dienophile end up cis, trans groups on the dienophile end up trans. Sometimes you may hear the terms syn and anti, which is also valid. So cis groups on a ring are sometimes called syn. Trans groups on a ring are sometimes called anti. So now let's look at two variations of the reaction that we started with and look at one where the two nitro groups are cis and one where they're both trans. In both of these reactions, what we're going to get is a cyclohexene ring as the core. So we can start by just drawing that. Then don't forget that this carbon right here has a methyl group. So draw that in. That's on a double bond, so you don't have to worry about three-dimensionality there. Now we want to look at the four carbons, or I should say two carbons on each structure on the top and bottom. That's where the nitros go. But we need to draw those with correct stereochemistry. So what we see is that in the first reaction, the two nitro groups are cis. So now if we come over to the product, we want them to be cis. And we could draw those both on wedges and make them cis, or both on dashes. And in fact, these are the two enantiomers that you would get in the reaction. In our bottom example, the two nitro groups are trans at the double bond. That means on the ring, they're going to be trans or on opposite sides. So we can draw a product that has one out on a wedge, one back on a dash. Or we can do the opposite, where the top one is back on the dash, the bottom one out on the wedge. So just make sure you keep this in mind when you have two substituents like this on the double bond. If it's a mono-substituted double bond, then you don't have to worry about the relative stereochemistry between the two groups. One other area where stereochemistry is possible is going to be if you have a group attached at this carbon or this carbon of the diene. In the product, you end up with a new chiral center. That gets a little more complex in the scope of this course, so we're not going to do any examples with that. So that's not something you're going to have to worry about in this class, is stereochemistry at these positions.